We have 2 more minutes before we go live. We have 1 minute before we go live. So just a final request to all the speakers to please maintain their timelines, so that we can follow the webinar. And also a request that, the questions in the Q&A box will be shared with you after the event is over. So I would request you, if you refrain from answering any of the questions in the Q&A box, because what happens is if you answer that question, it goes from the Q&A box, and then if I have marked it out for me to ask it, it becomes a problem. So just a request, please don't answer any questions in the Q&A box. We will be sharing the questions with you post the event. Also, my colleague Bhaskar is going to be my backup today. So in case anything happens to my link, Bhaskar will take over and smoothly conduct the webinar. So we are going live now. Ram, if you can go live, we'll give 2 minutes for the audience to settle down.
Yes, sir. I'm making it live.
Santosh, a request if you could start your video feed, please.
I'm going live. 1, 2, and 3.
To all the participants, we will be starting in 1 minute. A very warm good afternoon to all the participants from India. Good morning to participants from Europe and the US, and a good evening to participants from Asia Pac. My name is Kailash Shirodkar from Smart Water and Waste World magazine, and I welcome you to the final episode of season 1 of the Industrial Water and Effluent series. It is, I think, a coincidence that the final session has coincided with World Water Day, and I wish all our speakers and all our participants a very good World Water Day. I was reading some statistics that were there in newspapers in India today, how 30% or 40% of people in India in the next few years will face severe water crisis, or that by 2050, 6% of our economy or GDP would be lost because of water crisis. This just goes to show how important this resource has been. And while we always knew that water was precious, I think now is the time where both the utilities, the government, people at large, and at industry and technology providers need to work together to conserve or to manage this resource properly. For us, at Smart Water, it is not just mere symbolism of having sessions or a print publication or webinars. In the last 2 years of our existence, we have done a lot of workshops in deep industrial hubs across the country like Taloja, we have done Ludhiana, we have done Panipat, we have done Vijayawada, Guntur. Our effort has always been to identify industrial hubs across the country and, to engage with the community out there in the problems and issues that they face around water management and treatment. The last 2 years have also seen us work very closely with a lot of municipal corporations as we do specific workshops and sessions for them around the various water and wastewater initiatives that they have. And in line with that, I would say philosophy, we today on World Water Day have a fantastic lineup of speakers for you from across Canada, Norway, Denmark, and Germany. And I'm sure that the knowledge and the experience that they will share with you today would go a long way in helping you firm up the strategies that you have for treating the water and wastewater effluent in your industries. So without taking too much of the time today, I would like to invite our first speaker for the evening. The session is Forward Osmosis, Enabling Cost-Effective Water Reclamation by Dr. Howie Honeyman, CEO for Forward Water Technologies Canada. Over to you, Dr. Honeyman.
Thank you very much, Kailash. Hope everybody can hear me. Welcome. I appreciate everybody's time and attention to this, and I'd like to thank the organizers for putting on the webinar. I'm very excited to present, and I'd like to begin the presentation. If we could share slides. I will be presenting our forward water or forward osmosis process, but I'm also here representing our partners as well. Aquaporin, who is a membrane technology that we use for our process, as well as our industrial partner in India, Goldfinch Engineering, who will also be presenting part of the technology. And if we could get the title slide, or we could get the video queued up. I'm excellent. So just briefly, we have a short video that one of our providers, our membrane provider, Aquaporin Membranes, has provided to give people context on what forward osmosis is. Please begin.
Many industries such as textile, semiconductor, and automotive are massive water consumers and polluters, often in areas where water is already in short supply. As a result, factories are under increasing pressure from governments, local communities, and consumers to use less water and minimize pollution. Industry wastewater often has a complex composition, with many toxic chemicals and low biodegradability. The good news is that Aquaporin has a forward osmosis solution which solves many of these challenges. So how does this forward osmosis solution work? The key is Aquaporin's patented membranes, which separation layer has aquaporins embedded, the proteins responsible for transporting water in all living cells. They ensure that only water can pass through the membrane, while unwanted compounds are rejected. By means of osmotic pressure difference between both sides of the membrane, the wastewater gets concentrated, while the draw solution gets diluted with the extracted clean water. A recovery system then separates the clean water from the draw solution. The recovered clean water can be reused, while the concentrated and reduced volume of wastewater can be disposed and sent to waste management. If your plant uses a zero liquid discharge system, the improved recovery rate also helps you cut energy cost, since the volume of concentrated wastewater that your evaporator needs to process is reduced. As you can see, forward osmosis allows you to minimize waste and reuse more water. Moreover, it helps simplify your treatment process while reducing costs. It even takes up less space than other treatment systems. What's next then? At Aquaporin, we can advise and assist you all the way from initial feasibility testing to full-scale operation, so you get a solution tailored for your exact needs. Our goal is clear: to ensure the sustainable reuse of water in industrial applications. From our base in Denmark, we're working with local and international partners to solve this global problem. Are you ready to join the clean water revolution?
Excellent. So thank you for presenting that, and we could go to our presentation. I think that gives everybody an idea of what forward osmosis can do. And forward osmosis, the way that we have presented the technology to industry, is we are taking and targeting wastewaters that are so complex that they're only sent for disposal by brute force methods. That is, they're either burned, buried, or boiled. And that's because there's no viable treatment pathway for these wastewaters. So on the next slide, what we're imagining is designing factories that are capable of reusing water as a permanent piece of its infrastructure by taking that toxic water, taking that polluted, compromised wastewater, and reprocessing it so well that it can be resent back for reuse, used over and over and over again as a ongoing tool for production, or that clean water that's produced can be sent for other purposes such as agricultural usage. We think that this is a perfect way to introduce minimum liquid discharge or zero liquid discharge processes, allows water to be used as a tool, and doesn't create water stress in regions where there's already water problems occurring. We're currently ready to commercialize the equipment in transportable, containerized, large-scale commercial units. And in India, we're working with our partner Goldfinch Engineering to deliver the technology to India. On the next slide, this is how the process works. We saw in the video that the membrane process is fundamental to separating the water and rejecting the contaminant components. That we can see on the left-hand side of the diagram, where water is put in contact with the membrane. That special membrane, in our case, we use the aquaporin membranes, transports only water across that membrane with no applied pressure in our situation. And the reason that happens is because on the opposite side of the membrane, we have a highly engineered, well understood draw solution that creates a massive osmotic potential to pull the water and only the water across the membrane. Once that process is complete, we then take the spent draw solution and send it to a thermal stripper where small amounts of energy, solar thermal, could drive this process, allows that salt material to convert from a dissolved salt into two gas components. And those gas components are evaporated out of the top of the column, leaving behind clean, fresh water that can be sent for agricultural use, reused in operations, or any other purposes that fresh water could be needed for. And we go back from them, capture those gases that originally came off the top of the water, recombine them in a small amount of water to a concentrated form, and reuse them in the front end of the process. So what we've done is we've used a low energy separation process with a low energy regeneration process to reuse the draw, produced fresh water, and done so in a closed chemical loop. None of this requires exotic materials of construction, and all the equipment is, not only is it off the shelf, but it is equipment that you can order and design and fabricate today. On the next slide, this allows us to address a wide range of opportunities. And again, this is wastewater that can't be treated using current technologies today. We can treat cooling and boiler blowdown water. We can treat pharmaceutical wash water. RO reject, as an example, where the reverse osmosis process has created a concentrated brine that is typically sent for disposal. We can actually treat that brine and extract even further fresh water from that material. Again, minimal liquid discharge or zero liquid discharge is appropriate for that type of use. And that allows us to produce and manage water in a way that is low energy, uses less energy and subsequently has less greenhouse gas output and improves process efficiency. In many cases, we can reuse up to 90% of the original waste volume as fresh, clean water, and that allows us to replenish supply from municipal sources, reduces discharge that goes for final disposal, and allows us to create, in some instances, create water that local industries could use. On the next slide, here are some case examples that our partner Aquaporin has advanced. For an example, textile wastewater, where small amounts of trace dye in the waste stream could be recaptured and reconcentrated, while at the same time reducing the amount of volume of disposal and extracting much of the water as clean, reusable water. You'll also notice that there's an exceptional rejection or elimination of COD contaminants as well. Please, on the next slide. Another example is value recovery from digestate biogas production, where forward osmosis can come in, can concentrate a waste that ends up being turned into a fertilizer, while at the same time extracting water, clean water, for operational reuse. And again, this is an example of not only are we extracting dissolved minerals, but COD and total organic carbon are also significantly rejected as well. So we can see there's utility, and we can see that the output of clean water has value as well. So what we're doing is we've created a system that can extract fresh water from untreatable wastewater that also produces clean water streams that can be used again in manufacturing or by the local community. On the next slide. So overall, with our partner Goldfinch Engineering and Aquaporin, we've been able to deliver a pilot unit that is currently being operated in India, and pilot plants will simply follow the project outline that we've indicated here. Over the course of 1 to 4 months, we can demonstrate the technology on site. And I'd like to introduce Santosh Pride, who is the Director of Engineering at Goldfinch Engineering, and he will walk you through their capabilities and what they're doing to advance the technology and commercialize it within India. Santosh? Santosh, you're on mute, I think.
Yeah. Hi, thank you, Howie. So basically, you have learned about two innovations. One is about the membranes, which facilitate extraction of water at very low energy, which is Aquaporin's hollow fiber membranes. And second is the innovation on the draw regeneration side, which Forward Water Tech has done. I will be as Goldfinch. Basically, we are looking into application and delivering that application to India. So I will be talking about how to integrate both these solutions when giving ZLD solutions to Indian industry. So as you can see on the slide, we have got a lot of experience on the industrial wastewater, though we have got different laterals on consulting and feasibility and EI and these things. So we were looking at various state-of-art technologies, and since last 3 years, we have done a lot of work on this. Next slide, please. So, yeah. So we have a very good laboratory backup to assess the results of these studies. And as you can see on the right-hand down corner, there are some fixed and some portable units already, which we are using extensively for taking on customer sites and studying the feasibility of this solution. Yeah, can I have the next slide, please? As this is the outcome, this is a plant dedicated for on a larger capacity. As I said, 12 to 18 KD is the throughput, which is deployed in one chemical industry in Maharashtra. And we have started the trials. I hope to give very good, results in another 1 month to 2 months time on validation of this. So if you see on the central side, that is the forward osmosis side. On the right-hand corner is the draw regeneration columns you can see. So this is already operational at the site. And okay, keeping in mind the space availability in industry we have kept it flexible. Initially, we were thinking of having a containerized thing, but then we made the design so that it can be collapsed and customized to fit into the required available area. So this plant is available for deploying at various sites. Next, please. So I would like to just touch upon how we can integrate the forward osmosis system in the ZLD plants, because ZLD plants is a need and it is a statutory compliance requirement, as well as it drives because of the water scarcity in India. But the cost of operation of these plants is very high. So we believe that this process will, on integrated with the ZLD solutions, will bring down the OPEX very much. The first arrow you can see is after the primary treatment. Of course, based on the type of wastewater and other detailed analysis, we decide we can do away with the entire conventional treatment plant, which is the train on the top to appear, and concentrate the wastewater which goes to evaporation, and we recover the permeate, which is at the bottom of the slide, through our recovery system, which is a water good for secondary. We can also do it after the biological treatment. If it is a biologically biodegradable wastewater, it is always good to go that route because it is a economic route. And then we can do away with the tertiary treatment and the reverse osmosis. That is another option. And the third option is we can, in the existing plants, we can have this system integrated in between the reverse osmosis reject and the evaporation feed to further concentrate, because using this process, we can, of course, depending upon the wastewater analysis, we can concentrate it up to a TDS of 200,000 ppm. Next, please. So we took up 3 case studies and made projections. We did extensive sample collection and ran it through the HFFO membranes. And the 3 diverse studies. One is a high concentration wastewater in terms of TDS. Second is a pre-concentration feed to evaporation. And third was where they are thinking seriously of replacing the entire biological ETP, just a 2-step process. Next, please. So if you see the analysis, okay, I am not that other parameters are not important, but I have just, for the sake of simplicity, put here only dissolved solids and COD. So unlike, so TDS is very high in the first case, almost like 1 lakh. Still, there is about 50% recovery is possible here. And in the second case, which is a feed to evaporator, we will be able to cut down the evaporation cost by 70%, because we shall be able to recover 70 KLD of water from that 100 KLD. In spite of the COD near 10,000 in this case. And in the third case, where there is a 200 KLD conventional ETP, which is consuming a lot of footprint, and that is a problem for this user, we can replace the entire process by forward water, osmosis and recover 80% water. So the entire thing becomes very workable for them. Next, please. We compared mainly the 2 important utility things. One is the electricity and second is the steam, which drives the operational cost. We also compared the space and of course the cost at the end. So if you see in all the 3 cases, the electrical energy is a fraction of the conventional. You can see the conventional compared with the FO-based system everywhere. The steam requirement is also very less. And except for the third case, it is marginally high because we are replacing the entire plant here. And the footprint required is always less in all the 3 cases. Especially in the third case, the footprint is only 30% of the conventional ETP. If we see the capital expenses, in case 2 and case 3, we see that it is always, it is only less than the conventional process. And in the first case, though the capital expenses are more by about like 25 million rupees, the operating cost saved per day, the return on investment is just less than a year, just 1 days. So these are the projections based on the studies, and of course we'll be deploying the bigger pilot plant to weight this further. But this gives a very good, brings out the potential of this process. And integration into the ZLD systems, because it offers a better feasibility. We always know that there are issues in the ZLD plants, because especially when the high COD and high TDS combination comes, which can be overcome. So better compliance is possible. We can extract water for recycle. It is a more efficient process. It reduces energy, reduces the operating costs, reduces the footprint also, and easily possible to retrofit in the existing systems as well as for new systems. So I think this offers a very good standalone or integrated solution when we are talking of industrial wastewater zero liquid discharge systems in India. Yeah, that's it. Thank you.
Thank you,
Excellent.
Dr.
Thank you very much.
Yeah, Dr. Hovi, you want to continue or should I take some questions?
No, please take some questions, Kailash.
Okay, so I have my first question from Thirumurugan Pandian. I mean, either Santosh or Dr. Hovi, you could answer this. The question is, can forward osmosis be applied for desalination plants to increase the recovery rate up to 65%?
So I think forward osmosis is suitable for desalination, but I think the best use of it is after reverse osmosis to treat the brine discharge from the initial reverse osmosis process. This would make the reverse osmosis process more efficient, or the overall process more efficient, and use forward osmosis where it's going to have the greatest impact.
Okay, I have a question from Mangesh Basmatkar. He's asking, how is forward osmosis technology acceptance and maturity in the Indian context? Santosh, maybe you want to take this?
Yeah, of course. As I told, since last 3 years in India, we have been doing studies with different type of industrial wastewaters, not a particular type of industry. So like having high COD, low COD, high TDS, low TDS. This, of course, this route is more suitable. Actually, it debottlenecks the requirement when there is a high TDS and some COD also in the wastewater, where other feasibility is very less. And we have found very good results. So I would say, though, yeah, it is at the inception stage we are entering, but I'm sure in a few months to go, we'll be probably bringing up the first commercial installation in India.
Santosh, when you were presenting, Prabhat Goyal has asked this question. May I request a little bit more information on the recovery system of diluted draw solution?
Yeah, probably Hovi can take this.
So we're happy to supply some additional information. My contact information, I think, is available through the webinar. Of course, that is our proprietary technology. I'm happy to describe its performance under the right conditions, but absolutely would provide more information on it.
So, Dr. Hovi, since as you said it's proprietary information, I would send across the details of Prabhat to you. Maybe you could, respond to him, post the session is over.
Absolutely, absolutely. I'd be happy to. I can say that what we do is we use an amine complex with CO2, and that's a reversible reaction that allows us to make the salt, use it for its osmotic potential, and then take it apart into two gases. But happy to discuss offline as well.
Chaitanya Shroff is asking this question: what is the maximum TDS that the forward osmosis can handle?
I think, Santosh,
yeah, 200,000 ppm is what
I think that's fair. I think it's optimal from where reverse osmosis stops all the way up to 200,000 ppm.
Okay. Kashif Shabir is asking, can you tell us more about HDI and turbidity of forward osmosis permeate?
I'm not sure what you refer to as HDI.
Okay.
SDI.
Oh, Santosh?
Yeah, basically wants to know about silt density index. What I would say, the permeate from forward osmosis from the draw regeneration system is a water which will be having TDS of less than, say, 500, some cases less than 300 also. So it is a good water for secondary use. And if you want to really go for more critical processes, probably you'll have to put it through your process RO system prior.
I would agree with that. That's our experience as well.
Okay, Deborah is asking this question saying, thanks Dr. Hovey for the presentation. If I understand well, the osmotic pressure does not affect forward osmosis. Is that right?
Well, forward osmosis is an osmotic pressure-driven process. What we're able to do with our draw solution is create an osmotic potential of over 200 bar. We think it's around 220 bar. And that allows us to extract water from a fluid that already has a significant osmotic potential as well, but we can overcome that potential.
Okay. Dr. Sandhya Singh is asking, is this applicable to phenolic effluents?
That's a very, I would say yes. I would say yes, but that would require a specific study. The key part there is, can the membrane reject the phenolic contaminants? And that's a typical bench study that we do. Once that has been proven, and often we're quite successful with the aquaporin membranes, the regeneration process remains the same.
Okay. Bhaskar Datta is asking this question, can forward osmosis technology be used for wastewater recovery which is high in fouling matters such as high COD, TOC and hardness?
Yeah, high COD definitely yes. Hardness, of course, we can take a little more than the conventional RO process definitely, but we'll have to ultimately see what is the precipitation point for whatever, because it is passing through membranes, though our membrane pore is more higher, but we have to take care that it doesn't precipitate inside the membrane.
Okay, I'll take two more questions. Azakation is asking, how is forward osmosis technology cost effective when compared with electrolysis technology?
The draw regeneration is where the energy is consumed in the forward osmosis process. And the fact of the matter is, because of our proprietary salt that we use, it only requires a small amount of energy to drive the regeneration cycle. And in many cases, you could in fact use solar thermal sources and subsequently not require any power input other than pumps to move water around. So the energy footprint can be very, very good.
Okay, Titus Praveen Kumar is asking, what is the maximum TAN, TAN and TSS limits for forward osmosis feed?
Well, TSS, of course, you have to remove before any membrane process, but unlike RO, where you probably need to go for ultrafiltration, we can take the wastewater in after only microfiltration. So anything less than 50 micron is good enough. We can pass through the membrane normally. So the pre-treatment reduces in case of forward osmosis compared to reverse osmosis. So that is about TSS. And what was the second part?
TAN, TAN.
Yeah, TAN, yes, we have to see the rejection of TAN, and basically probably we'll have to play with the pH of the feed to see that TAN doesn't pass on the draw side. So we'll have to take some specific study if that is a specific wastewater which is having the TAN problem.
Okay. I will take one final question before we go on to the next speaker. So Dalip Chatwal is asking, what about bacteria removal in forward osmosis?
Well, bacterium are quite large, and they're generally going to be rejected by the membrane as well. But I would be cautious in making that statement. It's not something we typically study, so we would have to go and look at that specifically. But bacteria tend to be quite large and shouldn't make it through the membrane.
So Dr. Hovey and Santosh, there are still a few questions left which I will take maybe after our next speaker is done. We have kept a 15-minute time frame to answer additional questions. So thank you very much for this session, and I would request you if you could hold on, for more questions in the Q&A session.
Sure.
Absolutely. And again, thank you for the opportunity, and thank you for everybody spending your time listening to us. Thank you. I appreciate it.
Thank you.
Thank you. Our next speaker for our session today is Dr. Mrutyunjay Chobe, a well-known, person in the water and the wastewater community in India. He's the Global VP Environment and Sustainability at UPL Limited, and he's going to talk about the techno-economic feasibility of zero liquid discharge in industries. Over to you, Dr. Chaubey.
Good afternoon. Uh, Thank you. Thank you for inviting me in this webinar, Industrial Water Effluent Treatment. I think this is the episode 5 of this series. So it's good. And am I audible?
Yes, sir, you are.
So, and also it is a coincidence that today is the last episode and today is World Water Day. So I want to wish everyone, all the audience, all the speakers, happy World Water Day. And before starting my presentation on zero liquid discharge, I want to I want to express my view related to water on this World Water Day. Since I am in industry from last 25 years dealing with water, environment, sustainability, what I feel that if we look India, then India doesn't have any problem of water, but it's only how we are approaching toward water. Because today, if we see the entire water demand of our country, India, is barely 3,000 billion cubic meter. And if we see the rainwater, the rain precipitation, which happens in India, that is nearly 4,000 billion cubic meter. It means nearly 33% rainwater we get in India. And that is a fortunate for us that nature used to give 33% more water than what is our total demand of country. But still we are struggling and day by day a scarcity is coming. Why? Because we don't able to utilize the rainwater. So at this moment of time, we used to utilize only 35% rainwater. So that comes around 1400 billion cubic meter. Rest 65% goes into ocean and that get wasted. And that's the problem with us. If we can start collecting more rainwater and using, then I think we have enough water, even more water we get from nature, what we want in India. And that's the ground reality. I think to utilize the rainwater, I feel that the interlinking of river, that is also one of the necessity. And unless until we do the interlinking of rivers, we have issue and problem of water. But interlinking of river is the bigger project, and more capital expenditure is required, and more willpower from the government is required. So, but at the individual level, we can try to collect more and more rainwater through the rainwater harvesting, and we can utilize. That is the main solution. Now coming to my topic, which I am going to speak on techno-economic evaluation of zero liquid discharge in industry. So there, before starting the presentation, because my presentation will be technical in nature, but I want to share two things on the ZLD also. One thing is that concept of establishment of ZLD may be good, but we cannot generalize and we cannot implement uniformly throughout the country. And why I used to say this? Because if we see the pollution out of ZLD, and if we see one is the water pollution, another is air pollution, another is the land pollution, then yes, for water pollution, it offers the best solution because we recover all the water, we use the water. So it's very best and good to address the water pollution. But at the same time, ZLD consume a lot of energy and a lot of carbon emission happens with ZLD. So it's not good for the air pollution because it enhances air pollution in environment, and also a lot of hazardous waste get generated. So it's not good for the land pollution also because it enhances the land pollution. So we have to take balance between water pollution, air pollution, and the land pollution. And when we apply that balanced approach, then we found that the coastal area where very good treated wastewater discharge facilities like deep sea discharge are available, then we recommend that don't go for the ZLD, just meet the discharge standard and then discharge into the either deep sea or wherever the discharge facility is. But in those areas where there is no proper treated water discharge facility and extreme water scarcity is there, so in those areas, yes, ZLD can offer solution. So let's go for the detailed presentation, and just I am opening. Okay. Okay, so I'm just making on the slide mode. Is it coming? Presentation is coming on full screen?
Yes, sir, it is coming.
Okay, fine. So quickly in this presentation, what I shall do, I shall explain first about the ZLD, just to set the context. Then all available technology, commercially available technology, that I shall brief. Then feasibility study, we will see that whether ZLD is feasible, and then the alternate solution of ZLD, and then at last I shall cover some of the important features of my book, which I have recently published with Wiley publication. Now this is about the zero liquid discharge. So those people who know about the ZLD, for them it is a introductory kind of things. But here what I want to show through this slide, that when we talk about zero liquid discharge, then we inside the industry, we first do the primary treatment, maybe with the conventional ETP. Then at tertiary stage, we install reverse osmosis, and the brine or reject coming from the RO that goes to evaporator, and from evaporator again we use the crystallizer. So by this way we used to achieve the ZLD. So this is a conventional ZLD, and how we can reduce the cost and the area occupancy through other kind of technology, that also I shall cover in the next slide. But this is about the conventional zero liquid discharge system, where normally industry used to put conventional ETP, then the membrane technology, RO, and evaporator and crystallizer. Now coming to the some of the technology which we came across recently for the ZLD, and our experience happens to be, so first we implemented a scale van, and in a scale van what we found, that this is a very good technique and techno-economic solution, where treated wastewater from the ETP directly can be recycled into cooling tower without using much more energy and the chemical. So it is a very cost-effective technology, and we are using a scale van at several places, and we found that it is very good, and we can recycle and reuse water, treated water from the ETP inside cooling tower as high as 250,000 ppm TDS, and very small blowdown happens. Second is RO, reverse osmosis. So I think everyone know that RO is a very popular technology, but the problem with RO is that the fouling happen. If the more organics, like more COD, if comes, or more biological impurities come, or heavy metals comes, then the RO doesn't happens to be very effective. But if there is a no COD, very less COD, and the TDS is below 5,000 ppm, and no heavy metals are there, then RO work very perfectly. And the RO reject which comes, that's become a problem, and that may be treated with the multi-effect evaporator. Then forward osmosis, I will not take much more. This is a new technology, but I think past presentation cover detail about the forward osmosis. And I was just going through the last presentation, and yes, we have also implemented forward osmosis. Just we have commissioned 2-3 months back, and we got a very good result with the forward osmosis. And I can say that forward osmosis may be the technology for the future. And then last, multi-effect evaporator. So multi-effect evaporator, everyone know it is a conventional technology where evaporation technique get used, but it is a very costly capital cost and operation cost. Both comes very high. Area occupancy also comes very high, very high. But yes, if you want to ZLD, then you have to think galaxy of technology, several technology, and then you can use as per the requirement, and then only you can get a cost-effective zero liquid discharge system. So I think that we can say that the concept of establishment of ZLD may be good, but it cannot be generalized and implemented uniformly throughout the entire country. At it emit more carbon and more hazardous solid waste get generated. Now here some of the practical information which we able to get by implementing into the industry. And you can see that I have mentioned here various ZLD technology like a scale ban, RO, forward osmosis, vacuum distillation, multi-effect evaporator cum crystallization. You can see that first is about the power consumption, and second is about capital cost. So left hand side, if you see the power consumption, then you will find that the power consumption is very minimum with a scale band technique, then slightly higher, maybe 3 to 5 kilowatt hour per cubic meter with the RO. Then the forward osmosis comes in range of 5 to 10 kilowatt hour per cubic meter. Then the vacuum distillation may be between 15 to 25 kilowatt hour per cubic meter, and ME cum crystallization that goes between 25 to 40 kilowatt hour per cubic meter. So this is the power consumption associated broadly with these technologies. Now right hand side, if you see the capital cost, then RO we end with less capital cost. There may be nearly 50 to 100 rupees per cubic meter. Then a scale ban cost around 150 to 200 rupees per cubic meter. Forward osmosis in range of 300 to 400. Vacuum distillation maybe in range of 1,000 to 1,500, and then ME. So ME goes as high as nearly 2,000 to 3,000 rupees per cubic meter. So if you see the power consumption and capital cost, so this is the main reason why in industry we have to think to utilize all this number of technology such that we can achieve the zero liquid discharge in a techno-economic way. Now another example here you can see in this I have tried to show you a stage-wise operating cost and a stage-wise power consumption. And if you see a ZLD plant, then this may be a conventional ZLD plant where effluent is coming, and then we have a biological treatment plant. After that, reverse osmosis is there, and from reverse osmosis, reject get treated in the multi-effect evaporation. And if you see the operating cost, then in ETP maybe 500 rupees per cubic meter, And in UFRO section, you may end with 136 rupees per cubic meter, and in AME, it is 3000 rupees per cubic meter. So this is the typical example I am giving with a 1 MLD plant, which we have, and TDS around 3000 to 4000 ppm, and COD 4000 to 5000 ppm. Now, with the difference in characteristics, these all operating costs also go on differ, but just I have given one practical example, what exactly we are getting to give the picture. And if you see the overall cost per cubic meter, then in ZLD, it's coming nearly 1500 rupees per cubic meter operating cost overall, including ATP and the RO and ME altogether. Power consumption also you can see the stage wise, and the overall power we are getting 13 kilowatt hour per cubic meter. Now what I want to show with this slide is that suppose one ETP you want, where you want to just achieve the discharge standard, then you have to just install ETP biological treatment, and you can achieve the discharge standard and you can discharge into the stream. But if you want to achieve ZLD, then you have to again incorporate RO and ME. And here the lesson from this is this, that the operating cost to meet ZLD norm is 3 times higher to meet the discharge norm. And the CO2 emission to meet ZLD norm is 4 times higher to meet the discharge norm. So operation cost, CO2 emission, hazardous waste generation, all are very high in the zero liquid discharge plant. Now this is some of the graph which is showing power consumption between ETP to meet the discharge norm and ETP to meet the ZLD norm. And you will see here that the power consumption in ZLD is 4 times higher to meet the standard norm. And then you can see the solid waste generation, which is 2 times higher. You can see the CO2 emission 4 times higher in ZLD as compared to conventional plant, and chemical consumption is 2 times higher as compared to conventional plant. So by this way, capital cost also you can see nearly 3 times, 2.5 times higher, and operational cost is 2.5 times higher. So based upon this finding, we can say that zero liquid discharge is no longer an environment friendly technique, especially in coastal areas. And if you want to study more detail, then I have published one technical paper in Indian Chemical Council Journal, and there a detailed study along with data I have presented, and that paper has been published. Now this is again a tabulated form that how power consumption, CO2 emission, solid waste generation, chemical consumption, capital cost, operation cost are ETP to meet the discharge standard norms and ETP to meet the ZLD norms. So here what the summary is that the power consumption is 4 times higher, CO2 emission is 4 times higher, solid waste generation is 2 times higher in ZLD as compared to the normal ETP, and chemical consumption is 2 times higher, capital cost is nearly 2.5 times higher, and operating cost is 3 times higher. Now, after ZLD, what I found that most of people say that ZLD we need to implement. Why? Because we recover the water, and water is needed in industry. So in the interest of water use, we have to implement the ZLD. But I think if you see here, then that logic also doesn't hold good, because if you are recovering the water through ZLD, then you can see what is the water cost. It's coming nearly 750 to 1200 rupees per cubic meter. If you are taking the water through the sea, desalinated water, then the cost will be around 50 to 80 rupees per cubic meter. And suppose from nearby sewage treatment plant, municipal sewage, if you take the treated sewage and treat again inside industry and use it, then it will cost 30 to 35 rupees per cubic meter. And the rainwater, you can see less than 10 rupees per cubic meter. So here it's very clearly that in industry, if supply water is available, then that is the best technique. But after supply water, or if it's not available, then rainwater utilization is very cheapest water source and very good water source. But the problem with rainwater is this, that it is not available all the season. Then the second best choice may be take the sewage water and treat it. And then third choice may be desalinated water. And ZLD is, I think, is the last choice because it's very costly. Now, here is the summary about my presentation, that considering the adverse impact of ZLD on environment, it has been suggested to implement effluent treatment plant to meet discharge standard norm where sea discharge facilities are available. And I think the best way is that we should reduce the water demand inside the manufacturing plant. There we should try to concentrate more and more. We should try to concentrate more on effluent stream identification, characterization, segregation, because that helps a lot. And also we should concentrate on the recycling and reuse wherever it is possible. But ZLD itself, we don't found that it is a very environment friendly technology. Now, in the interest of time, I will conclude my session on the ZLD. Now, this is just, I will take 1-2 minutes regarding my new book. Just, I have published one book, Wastewater Treatment Technologies Design Consideration, and the IWET publisher, they have published this book. I have divided this book into 7 chapters, and you can see the name of chapter on this slide. The main purpose of writing this book is to present the practical data inside the book. So you will find I have covered nearly 30 kind of industry, more than 30 industry, which exact practical effluent characteristics has been tabulated. And also I have covered all the design methodology, design formula, where a simple person can also read, understand, and able to design the wastewater treatment plant. And I have also devoted one chapter 5th on advanced sustainable technology, where all the technology like forward osmosis, a scale van, volute, OH radical, which not available in any text, a standard textbook, those has been also included in this book. And zero liquid discharge has been also covered in this book. And last chapter is fully devoted on the wastewater treatment plant operational excellence. So it is a very good for the operator, the chapter 7. Now this is available on almost all e-commerce site. It is available on the IWET online library. It is also available on Amazon. So on Amazon site also it is available. And a part of this, it is also available on various e-commerce sites like eBay, Red Shelf, Booktopia, Layman's, and Waterstones. So I think you can order from all these sites this book. And so this is about my presentation. In the interest of time, I would like to conclude. If any question answer that we can take up. Thank you.
Thank you, Dr. Chaube. I know you have another session lined up, so I will take just 2 questions for you. One, Vishnu Rednam is asking, sir, what would your solutions be if we were to look at, shrimp process industry effluent treatment using ZLD?
Again, can you again repeat?
The question is that in the shrimp process industry, if they want to start using ZLD, what would be your suggestions be on the design approach?
So I think on ZLD, the design approach should be first segregate the all stream. And I think one technology, like in ZLD, sometimes people used to prefer all the effluent get treated with ME, or sometimes all the effluent with the FO, or everything with the RO. That approach doesn't found good with the ZLD. In ZLD, we have to utilize all these technology 2, 3 at the various stages, and then only we can get the better result. Another things I have explained in my presentation that we have found very good result with the scale van also, where the treated ETP directly can be utilized in cooling tower with the help of a scale van.
Okay, sir, I'll take one more question since there is a shortage of time. The question is from Olu Vadare. He's asking what is the efficiency and quality of discharge from ZLD and what is the impact of this wastewater treatment technology on the environment?
So that I think I have well explained that the main impact of ZLD is if you considered water and on water, yes, it good impact, no water pollution, minimum impact on the water pollution, and very good from the water pollution point of view. But if you see the air pollution, then it's not good because 4 times more CO2 emission happen with the ZLD. And if you see the land pollution, then also we don't recommend ZLD because more and more hazardous waste get generated through the ZLD.
Thank you, Dr. Chaube. I know you have another session to take, and I promised you I would let you go at 3:55. So thank you very much, sir, for taking time out of your busy schedule and sharing this information with us. Sir, thank you. Thank you very much.
Thank you. Thank you to everyone.
Can I request Dr. Hovi and Santosh if I can take some certain questions with them?
Yeah,
Please.
sure.
Yeah. So Santosh, we have a question from Tejasvi. Tejasvi is asking how feasible is forward osmosis for community STPs?
Well, basically community STPs, which is a low strength wastewater in terms of COD, BOD, as well as the dissolved solids. I would really not say that this is the best approach. Basically, we are trying to debottleneck things where we got more aggressive wastewaters from industries, etc. The biological treatment would be, of course, more cost effective in terms of sewage treatment.
Okay. A question from Vilas Wadhone is forward osmosis. Can it take care of solvents also?
No, solvents it cannot take because basically the membrane support layer is same like RO membrane, so it will damage the membrane. So we have to take off the solvents prior.
Okay, we have a question from Bipin Shah. He's asking, is pre-treatment required before sending it to forward osmosis?
Yeah, pre-treatment is required, but the pre-treatment is much less intensive compared to reverse osmosis. As I said, we do not require to go for ultrafiltration. Even microfiltration is quite good enough when we talk of forward osmosis. As far as the pH goes, of course, the membrane goes for a wide range of pH, but the suspended solid removal is very important. Of course, other solvents, if there are there, we have to remove them.
Okay. A question that either Dr. Hovi or Santosh can take. The question is from Praveen Khande. He's asking how expensive are these membranes for forward osmosis compared to that of reverse osmosis? And there are many people who have asked this question, how often do the membranes need to be cleaned and what is the procedure? Maybe Dr. Hovi?
I can't necessarily comment on the cost, but let me take the maintenance and issue. So forward osmosis is a much softer process on the membranes than compared to reverse osmosis. And there's been several studies, one by Modern Water that studied over a 2-year period, and they have suggested that forward osmosis maintenance has only 25% of the comparative reverse osmosis maintenance. So the maintenance costs are much lower. Typical membrane treatments such as backwashing are sufficient to regenerate the membrane performance and remove any debris that's absorbed to them. So fouling is reduced, and subsequently that translates into the lower maintenance requirements.
Okay, Mohammed Wakar is asking this question that textile industry is one of the biggest users of raw water. Can forward osmosis technology help in the complete reuse of water for after the dyeing process?
Yes, I think that's one of the best uses for this particular technology. We've had excellent results in our hands treating textile waters. I know Aquaporin has had similar data. We presented some of Aquaporin's data, and I think Goldfinch recognizes that's a specific industry that we want to solve that water issue for.
Okay, Mayur Dodia is asking this question. I need to know how efficiently forward osmosis technology in seawater application, specifically for power plant water cooled condenser operation. I know that's quite a long question, but do you want me to repeat it?
Santosh?
Well, actually, I would say I cannot really comment on it unless we evaluate the thing. So,
Okay, so Santosh, I will send across this person's contacts to you. Maybe you could reach out to him later. Okay, we have Fatima Zora who is asking this question. Does the draw solution of forward osmosis require a lot of chemicals to consume for this process?
So no, one of the advantages of our particular draw solution is it is almost 100% recycled, and there's no fugitive or chemical makeup required to continue the process. So that's what we think brings very, very compelling economics to the forward osmosis process or the draw regeneration that we're providing.
Yogesh Dingare is asking that can forward osmosis be used in dairy industry to remove fat?
There have been applications of forward osmosis specifically in the dairy industry. We would have to study how our draw solution with the aquaporin membranes would be appropriate for the dairy industry, but I do know that the membranes themselves have been successful in dairy applications.
Okay, a question from Subodh Dhiman is forward osmosis recommended for leachate treatment?
yeah, very much. In fact, there is a case study done by Aquaporin on leachate treatment, which is available with me. It is a suitable process.
And here in Canada, we're looking at industrial applications for leachate as well.
Surendra Patwardhan is asking a question to Santosh. While considering the cost of treatment of forward osmosis, what is the cost of steam and power that you have considered?
Well, okay, we have done for a specific case for that particular location. What is the steam cost for evaporation and the steam cost for regeneration of our draw? It is going to be same, but it may vary a little based on which fuel you used, which state of India you are based. The electricity cost may vary. So it is all the data which is directly available from the industry, specific industry for which we have done the case studies.
Okay. Kashif Shabir is asking, he's asked a lot of questions in fact. So the first question is, in order to feed RO reject into forward osmosis, do we need further UF to treat the RO reject first?
No, definitely not. Because it is RO reject, already it has passed through the RO membrane. Yeah.
He's asking, what is the pore size of the forward osmosis membrane?
The pore sizes are very, very small. So basically you only transport water molecules, but that's a membrane question. And I'd have to defer to our friends at Aquaporin.
Yeah, I think it's 200 micron.
Okay. He's again asking a question, can dyeing wastewater be directly used as a feed to forward osmosis?
We did some study for one industry where we concentrated this effluent and tried to recycle it back for dyeing. So we had success in that. Of course, it was on a small level. No commercial plant we have not done in India yet on that. But yes, there is a possibility.
Okay, Bhaskar Datta is asking the question, how hydrocarbons and emulsified oil affect forward osmosis membranes?
We've had success rejecting miscible oil, so small amounts of hydrocarbon that are dissolved in the water without any problem. Free oil or emulsified oil would pose a problem, would need to be treated prior to the membrane process.
Ashok Jain is asking this question, can forward osmosis be considered for potash recovery from seaweed? I think that's a very specific question. Maybe
yeah, probably we can connect with him and evaluate this further.
Okay, Dr. Sandhya Singh is asking the question, is it applicable for high TDS? What is the percentage reduction?
The percentage reduction depends. So at high TDS, we would remove water to the point where the feed solution became saturated. So if you're moving from, say, 15 weight% total dissolved salts, you would saturate at about 22 weight%, which would give you about a 25% volume reduction.
Okay, Dalip Chatwal is asking the question, is forward osmosis technology applicable for seasonal industries like sugar plants?
Yeah, basically when the question seasonal has come, probably it implies that for biological process, normally we have to run the plant continuously because the bacteria needs to be fed some food, which is the organics. In case of forward osmosis, it is a physical process sort of. So if we take adequate care in preservation of membranes, we can switch it on and off as required as per seasons.
Okay, Amrish Kumar is asking this question. My process RO reject water TDS is 6000 ppm. Can I install forward osmosis plant to increase reject water TDS?
Yeah, definitely.
Correct. And that the reject water from the forward osmosis process would take the 6000 ppm and upgrade it, if you want to call it upgrading, to about 24 weight%. So you would see a significant volume reduction.
Okay, to his further question on any supplier, I think Amrish, Santosh Bhide would be the right person to connect for any kind of solution in forward osmosis in India.
Yeah.
So Dhananjay Gudi is asking this question, has the forward osmosis been applied on the treatment of leachate generated from solid waste?
So we've studied that here in Canada on solid waste dump leachate, and yes, and have been successful at that.
Okay, I'll take 2 or 3 more questions. Peter Rubig is asking the question, can forward osmosis technology also remove nanoplastics?
I don't know. I would assume so, but we haven't looked at that specifically.
Okay, a question from Manyati is, how can forward osmosis be economically incorporated into a conventional aerobic wastewater treatment process, struggling with treating textile and food process dyes?
Basically, we have to go with a customized approach for each and every case. We have to say how it fits well, so the overall thing is economical as well as effective. So yeah, we can review the application and then where we can integrate the FO along with the other system that can be suggested.
Okay, Azakation V is asking a question, did the NaOCl content in the water affect FO membrane?
Pardon me, which content?
NaOCl. So am I assuming it's sodium chloride or something like that?
Oh, sodium hypochlorite.
Yeah.
I think hypochlorite is difficult for the membrane to handle. Yeah. Yes.
Okay, Rajendra Patil is asking, does it require any kind of chemicals?
No.
No, other than the draw chemicals, which we've mentioned are recycled 100%. That's it.
Okay, Dalip Moria is asking a question, can we use forward osmosis to concentrate an acid?
Depends on the acid. It is a pH limitation on the membrane, and the membrane acidity level is ranges between 2 and 11 are the operational ranges.
So I will take this final question, Dr. Hovi Santosh. It's a tricky question, but being a neutral media house, I need to take it. So the question is from Rajendra Kumar Saini, which one is more cost effective, forward osmosis or reverse osmosis?
They're different tools. They're different processes. Reverse osmosis is for low TDS strength wastewaters or seawater. Reverse or forward osmosis is for very high strength total dissolved salts. So they're not head-to-head competitors. They're different tools.
Okay, I'll take this final question. The question from Kondala Gonu Guntala is, can forward osmosis be used in municipal wastewater treatment?
Yeah, it can be used to, but we'll have to see the economics.
Correct. I agree. Municipal is very, very cost sensitive.
Okay, Dr. Hovi, Santosh, thanks a lot for taking time out of your busy schedules and addressing the questions that we have from the audience. Thank you very much. We will share these questions with you all over again, and in case you want to, reach out to any of the participants, you could do that directly. Thank you very much.
Yeah,
You're very welcome. It's
thank
been
you.
a pleasure speaking with everybody.
This brings us to our next presentation. I would now like to invite Filza Sheikh, process engineer for Binder Engineering, and Michael Bickendorf, again process engineering in industrial applications from Binder, Germany, to talk about aeration control systems, process safety, energy efficiency, and reliability, which leads to the key factors for clean water and environmental protection. Over to you, Filza.
Yes, good afternoon, everyone. Thank you, first of all, for giving us the opportunity to present here. We have been following the series right from the first session, and that's why we decided, okay, it's a very good platform, and we decided to present our technology. And here I have my colleague, Mr. Michael Bickendorf. He is the process engineer, but also an expert at the industrial water. And over to you, Michel.
Yeah, thank you, and hello to everyone. We are very proud to give you an overview over our solutions, especially here for this industrial sector. I'm working there in this field, for the business development of industrial applications, and I hope you will find some useful information from us. So I hand over to Filza.
Yes, thank you very much. And I will start the presentation now. Yes, can you see the presentation? A short feedback would be helpful.
Yes, we can, Filza. Sorry.
Yes, thank you. Thank you very much, and I welcome you all.
Could you just take the display settings, and on the top you have the display settings. You can make it full screen.
Yes, it is full screen actually.
No, right now we can see a side-by-side screen. The next slide coming on the right side. On the top,
Okay.
you have display settings.
Yeah.
You can just
give me a minute.
But I would do like this. It would be more comfortable to work with.
Now?
Yeah, perfect.
Okay. Yes. I welcome you all to our presentation, Aeration Control System for Process Safety, Energy Efficiency, and Reliability, which are the key factors for clean water and environmental protection. Yes. We here at Binder Group are located in Ulm in Germany, which is south of Germany, is the hometown of Albert Einstein, and which is also a technology hub. So our core business is in gas flow metering and control. Of course, the most important business segment is the wastewater treatment. So we are talking about the biological treatment or the aeration control systems in the biological treatment in the wastewater treatment plant. Yes, we have references in all the continents from small to big wastewater treatment plants. Decades of experience has led to our today's products. So now let's take a look at a typical aeration system. We have the blowers with the blower management systems, the pressure sensors and the lines with the water sensors, the airflow meters in the aeration control. We have the air control valve with the aeration control system in order to regulate the control valve and also to make the biological process much more efficient. We will be discussing about the aeration control in detail in the further slides, but this is just to have an overview about what we are talking about. And then you have the fine or the coarse bubble diffusers. So typically we are using the airflow rate into the control system because if many of you all are already aware about the German advisory leaflet from the German Water and Wastewater Association. They are saying to use the airflow rate, to consider the airflow rate or the airflow meters in the control system in order to avoid time delays, to have effluent quality as uniform in case of any rain events or any disruptions in the water effluent quality. And this helps in reducing time delays in the control loop of the aeration control system. So the red symbols that you see here, the airflow meters, the air control valves, and the aeration control is our scope of supply. It's very important to note that in order for the aeration control system to work efficiently, each component needs to be designed in a way that each component is energy efficient. And the most important and the vital part is the system integration. Only then can an aeration system work as per the expectations. The aeration control system. So what are the requirements for the plant? The process reliability and cleaning performance. So the vital task of the biological process is to clean the wastewater, and also the most important factor to consider here is that energy savings up to 50% are possible. And this is today a requirement because process efficient at the same time making or considering about energy savings. Very important when we talk about aeration control systems that they are user friendly because it has to serve as a tool for the operator that he can see what is actually going on into the biological process, and he has a tool in which he can make decisions but keeping the process safety in mind. Yes, and the technology has to be applicable to all kinds of activated sludge process. We have proved globally and achieved the results. So when you talk about an industrial wastewater treatment plant or a wastewater treatment plant, what is the most important and the vital part to consider? Process efficiency. You want the biological process to be efficient. Your expectations need to be met, keeping the effluent standards. But at the same time, what's very important is the process safety. Not just the process safety, what's also equally important is the equipment safety. Equipments like the blowers, the diffusers. So all of these three vital pillars in order to have an efficient aeration control system. And we often encounter that these are the typical challenges that people face today while running the wastewater treatment plants. So how can these be encountered? We will see in the next slides. So we now move to the conventional control valves. We are talking about air control valves. When we talk about aeration control system, we are talking about air. But the valves today being used were typically and originally designed for water applications. So from the physical point of view, it is clear that these have different working characteristics compared to a valve which is especially designed for air control. Yes, they're also non-beneficial due to lower accuracies. Of course, the water valves are lower in investment costs but have higher pressure drop. What does this mean? Higher pressure drop means higher operational cost, which means, yes, you're putting less money in the beginning, but at the end, your total life cycle costs are going up. And especially today, when most of the treatment plants and the wastewater treatment plants are concerned about running and operating for 5-10 years, then it becomes a lot more important to think about total life cycle costs and not just about initial low investment costs. Non-linear operational characteristics. Keeping it to the bare surface of not going into the technical, but what I would like to highlight is the typical water control valves do not have a linear operating characteristic. That means they cannot be operated the way they're desired. And thereby they have very less accuracy and repeatability. We will come to these important characteristics now. So what are the important valve attributes that one needs to consider? Accuracy and repeatability. So accuracy is a measure of how close an achieved position is desired to the target position. And repeatability is a measure of systems consistency to achieve identical results from multiple tests. So these two factors are ultimate goals, is only to have a highly accurate and a repeatable system. And like I said earlier, the typical or the classical water control valves being used today in the Indian market cannot produce, are not even close to giving an accurate and repeatable results. Most of them are typically shut off and on valves and not for control. Let's move on today, and now I come closer to our aeration control system. For the most of you all, this topic is relatively new, but I would like to put it in a much simpler way. In the biological system, we are talking about dissolved oxygen. So there is a dissolved oxygen set, and the operator is trying to maintain the actual DO very close to the dissolved oxygen set point. Number one priority by the aeration controller and the valve precision, which go hand in hand, we see the blue line indicates the dissolved oxygen. So you can see how the actual DO, I would like to actually start the laser pointer now. Give me a minute, please. Yeah. So you can see how actually the dissolved oxygen is varying, and this is the DO set, and the minimum required is pointed here by the red line. So what we can say and do is, with our aeration control and the precision of our valves, the dissolved oxygen set point can not only be reduced, considering the process safety in mind, but the deviations are also reduced, which is the prior and the first goal of an aeration controller. As you can see in the figure here, typically if you take a reduction in the dissolved oxygen causes typical savings on 10 to 30%. What I would like to highlight is, if the dissolved oxygen is reduced from 3 milligram to 2.5 milligram, you already see a saving of 20%. Typical savings, of course, it depends on process to process, and it is a load depending process, which means not always the same amount of air is required in the process. Now, what are the challenges and what are the expectations of an aeration controller? We all know how vital blowers are and how they need to be protected, because the air is being generated by blowers and these are expensive equipment. So we are trying to say, or everybody knows this in mind, avoid blower tripping. What are the expectations and events of this? Monitoring airflow rates, header pressure, and the limitation of minimum valve stroke. This is the reaction of an intelligent aeration controller. Clogging of diffusers. We all know the fine bubble diffusers system come with the manufacturer guidelines where they say, okay, in every 1 month, 6 months, they need maintenance by cleaning, diffusing, or giving a certain amount of acid. All of these, the intelligent aeration controller should be able to guide and run, automatically maintains these fine bubble diffuser systems. Breaking of diffusers. Diffusers are sensitive equipments, and to avoid by crossing the maximum airflow, we don't want to disrupt or break down these diffuser systems. At the same time, you want to maintain the efficiency of the diffuser systems because the oxygen transfer efficiency is an important factor. So the intelligent aeration controller has to not just maintain, also limit the maximum airflow. In case of a SCADA error, because the aeration control system is communicating with the SCADA, in case of event of failure of a communication, there should be a redundant PLC where it can independently handle the biological control. And the communication error, in case of communication errors, it should have fail-safe strategies. The aeration controller should incorporate fail-safe strategies in case of communication error. Now we come to the sensor signals. We know the sensor signals like the dissolved oxygen or the ammonia. These signals, what is important to know is the intelligent aeration controller should do the plausibility check. Not just that, it should also have substitute values and fail-safe strategies for these sensors. These are the expectations from the intelligent aeration controller. Now we come to our scope of supply. You see, we have the thermal mass flow meters for the airflow control. We have the aeration control valves. You can see here, this is a jet control valve. In the next slide, I will be explaining much more in detail about this. We have the elliptical diaphragm control valves, and we have the intelligent aeration controller with the flex algorithm, which has artificial intelligence. One thing which is very essential here is that all these components were typically designed for the biological process in wastewater treatment industry. Coming now to the vacuum-mass jet control valve. Most of you all might be seeing this. It is our Binder know-how. It is patented, and this valve was developed and optimized especially for aeration process. Like I said, unlike the other control valves, which were designed for water, which don't have a linear characteristic control valve, this has almost linear control across the operating range. The design is rugged, especially important for the industrial wastewater treatment plants where the requirements are so high of the material. It's made of high-grade stainless steel with protective, service-free for 20 years. As already mentioned, it is patented. What is most important is the pressure drop across the valve is 3 to 5 millibar. We are talking about extremely less pressure drop compared to the conventional pressure drops. And the special Venturi design is actually designed in a way because it is a Binder know-how and it's a patented product. The Venturi design helps in the pressure recovery. That's how most of you all might wonder, how is it technically possible? Yes, for the control inside, there are 10 to 5 millibar, but across the valve, there's only 3 to 5 millibar. And at the end, less pressure drop means only energy savings. Coming now to the aeration controller. I already highlighted a few expectations of the aeration controller. What are the expectations? So our aeration controller, the highest priority is risk mitigation with intelligent process control. Keeping in mind the process safety, equipment safety, and real-time monitoring of sensors for proper functioning and maintenance. What's very important is the demand-driven air control supply at lowest operational cost. You might think, okay, it's artificial intelligence, it's an aeration controller, but this is a tool for the operator where he can learn to operate it in few hours. And this is applicable to all plant sizes, from small to big to up to 722, but this is practically applicable to all sizes of sewage treatment plants. Now we come to some of the results of our aeration control system and valves. You can see here. So what is this? There are many parameters here. To keep it simple, I would like to say the DO Act is blue color, and you can see here, this is the DO that we are talking about. DO set is, however, in between this. The point is, this is one of our case study. So it is a real plant case study. Without the vacuum system, you can see the dissolved oxygen, how it was varying, and it is almost unlikely with any other system to have this kind of precision. With vacuum system, you see not just that the dissolved oxygen actually is reducing, but the fluctuations are minimizing. We have many case studies, but because of the time restrictions, we would just like to show that we are not just speaking, we have results which have worked, and we are having many happy plant operators all over the globe. Coming now to the second case study, the first phase. What is very important in a biological wastewater treatment plant? We are talking about energy savings by reduction in energy consumption of flow. I probably forgot to highlight because biological treatment plants are one of the highest energy consumers in the wastewater treatment plant. And our result, you can see the blower energy consumption from the startup in a period of 4 months from March to April, how the energy consumption has significantly reduced to 28.4% results. These are significant in just a few months before you see this during the startup, and after the fine tuning of the parameters in the aeration control system, you can see a significant reduced in the energy consumption of the blowers.
We have 2 minutes left.
Yes. We come now to the second part where not just the energy consumption is reduced, but the improvement in effluent quality. So the total nitrogen was reduced by 20%, but also the min-max deviations became less. You can see during the startup and during the fine tuning how this result actually incorporated. So this is with our flex control, that is our vacuum mass, flex control, aeration control system. Some of the references worldwide in the wastewater treatment plants: Amsterdam, Auckland, Singapore, Shanghai, Milano, Ulm, Munich, Berlin, and Cleveland and USA. We have proven results all over the globe in the wastewater treatment plants. With that, I would like to end my presentation. Thank you very much for your time. And now we are open to answer your questions.
Thanks, Filza. We have a few questions that have come up during your presentation. So Dilip Chatwal is asking this question: do you have an online monitoring of dissolved oxygen in the process?
The online sensors, we are working with every online sensor which is been used in wastewater treatment plants. So in our scope of supply, we have the aeration controller, and we can read in all the online signals which come from the sensors.
Okay, we have John McGrath who is asking the question: can you explain how you are currently measuring nitrate as NO3N, and what part of the process are you taking their measurements?
We can take different signals into account into our aeration controller. So like, for example, NO3N. We are doing this also with, for example, with ammonia. So we are speaking then about ammonia-based aeration control, and we have different strategies, planned and project specific, which we can use. But this depends on the signals which are available, typically based on DO and airflow. Then we can expand this control strategies.
Okay. Ajay Patankar is asking a question. He's saying, is the elliptical shape maintaining the velocity of flow as circular? Ajay, can you repeat this question again? Because I think, it's getting difficult to answer.
Can you repeat this question? I did not get it totally.
Yeah, even I didn't get the question, Michael. That's why I've asked him to repeat the question to us. Dalip Chatwal is asking, how much depth of aeration basin for the treatment process?
The water depth, huh?
Yeah, the water depth, yes.
Yeah, Filza, I think it is the depth of the aeration basin.
Yeah, I understand. So what we are trying to say is all kinds of activated sludge processes, even when the tank height or the water depth is varying, our system can take all the parameters into account, and when there is air distribution needed, for example, in one tank the water is high and at the other time it's lower, all these things can be considered to our aeration control system, if I understood it correctly, his question.
So,
Okay.
changing water level means upper static pressure, and we take this pressure situation in the header pipe, we take this into account and we calculate the related stroke under the temperature pressure situation, which is online.
Stroke of the valve.
Okay. We have John again, who's asking a following up question. He's saying, has Filza or Michael considered using nitrate shunt for controlling the wastewater treatment plant as opposed to DO?
Is the question regarding ammonia-based dissolved oxygen control? When I understood it correctly?
Yes.
Yes, our aeration controller system has various function parameters, and we can also do ammonium-based dissolved oxygen control. Then, of course, we need the ammonia signals and the nitrate signals, like Michelle already defined earlier. We also do that. So that actually not just improves the process, but also gives much more energy savings. So we're already having energy savings with different functions that we mentioned, but this would additionally add to increasing the process efficiency, maintaining the effluent standards, and again, energy saving. Yes.
Okay, I'll take one more question before I go to the next speaker. So Peter Rubik is asking, how is pH value measured, and is there a change in the process?
So we are not into this pH value measuring. So we take also, we could imagine to take the pH value into account, but up to now, for all our control strategies, we don't use pH values up to now.
Okay, Nicholas is asking this question, what is a common problem that the aeration process encounters?
Common problems are, for example, over and under aeration. Over aeration is not good because you waste energy, and in case of an internal recirculation, you take the dissolved oxygen or too much dissolved oxygen into the denitrification zones, and under aeration leads to inefficient treatment of the wastewater itself. So these are some typical problems, beside of all these maintenance issues for the diffusers, for example.
Okay, so Filza and Michael, I would request you to please stay on, as you know, once we finish with the remaining two presentations, we will come back to the Q&A session. So thank you very much for taking time out of your busy schedules and sharing this information with us.
Thank you very much.
Thanks.
Thank you very much. We will be here for the next set of questions.
Okay. Coming to our next session, we have always tried to include with technology presentations a whole lot of neutral and industry perspectives. Our next presenter, Mr. Sri Pati, is an expert engineer with the International Center for Clean Water in India. He is going to talk about the water sustainable industrial production in industrial areas, paths for MSMEs. Over to you, Mr. Sri Pati.
Hope you're able to see me.
Yes.
You are able to see me, isn't it? My video is visible.
Yeah, your video is visible, sir. You could.
Should I share my screen?
Yes, sir. Please do.
Okay. Just for the benefit of quickly doing with the slides, I am trying to put it on my screen so that it will be easier for me to flip it and then discuss it over the next 10 minutes, I believe, because I have just started at 4:40 in my clock. So I believe this is going to take another 10 minutes, or I'm allowed for another 10 minutes, sir?
So, sir, you are starting at 4:40, so you have your 15 minutes.
Yes.
So you will end at 4:55.
Thank you. So thank you, Mr. Kailash, for the opportunity once again. It's been a wonderful time in the past 1.5 hours with several of the international and national experts participating in this. And good afternoon, good evening, good morning to all people who have joined from various parts of the world. I see a lot of participants from Uganda and Norway, Bangladesh, Pakistan, and several other places in the world. Thank you once again for joining us and for this particular session. Last but not the least session is again a bit challenging one to keep all of you in this particular session, but nevertheless, let me try and do this very quickly and very effectively. I'm going to talk about water sustainable industrial production in a small industry. In the sense, you might have known about very large industries. All the experts were speaking about very large, industrial establishments wherein ZLD, then several other high-end technologies would be required. Of course, they are necessary. They are necessary in a world where all these exist together in terms of large industries, and large industries would be supplied by the small industries. Small industries, as we all know, they are the backbone of any country's economy. And for India also, they are the backbone of the Indian economy. And our objective is to see how MSMEs function better and more efficiently in the span of water and wastewater in the context. Let me discuss with you in terms of what are the issues, challenges, and opportunities that we have in trying to address MSMEs, improvement in water use efficiency, and then several other aspects of water and wastewater which they may be dealing with. My content of the presentation would be something like this: short overview on MSMEs. Probably our colleagues from Germany, Norway, and other countries who would like to know about more of this kind of context on why MSMEs. What is MSME all about in the context of Indian scenarios of water and wastewater? What are the drivers for the water management, which again lead to wastewater? And then what are the drivers for national water policy? And do MSMEs need to plan? Do we have a plan? Why should they plan? And if at all they need to plan, what would be the approach? And some scenarios that will help MSMEs and the technology providers, like we have been hearing from Goldfinch and several others, on how to really approach this issue. A small suggestion is given here in terms of how we can think about reducing the so-called difficulties in the water and wastewater scenarios in the country, particularly the MSMEs. And one case example, which I have personally worked on in the past, I can give you some examples on how this was thought about, how it was done, and all that. And some interventions which currently ICCW, the International Center for Clean Water, which is an initiative IIT Madras, can help the MSMEs get rid of certain issues in the water and wastewater sectors in their day-to-day operations. Some deliverables that can help and way forward. Before getting into it, I would like to just touch upon this point that India as a country is racing towards the third largest economy in the world. Several initiatives, several long-standing initiatives have been put forth in the past and in the recent past also, and there is no limit in terms of putting technologies, putting their efforts, and all into the improvement of efficiencies in several sectors, particularly the MSMEs. MSME, as I said, it's a key engine growth for the country, and it contributes to around 8% of the total country's GDP as of probably 2015 or 16, or even more as of today. And 45% of the manufactured output, or 40%, goes to the exports. And it is employing something more than 60 million people. And the enterprises, number of million enterprises would have increased tremendously now after several schemes that have been launched. In the recent past, you might have heard about Atmanirbhar Bharat, Make in India, all those. This has given an excellent potential for people to join and developed several MSMEs across the country. There are several schemes available in the country. All that is possible, and we are seeing a boom in MSME sector. Towards this, water should not become a deterrent to this growth, to this kind of acceleration that we see in MSME growth. Water should not become a deterrent. Water, or even the generation of wastewater, its handling, its treatment should not become a deterrent. Let me give this as a perspective from a larger point of view compared to the industry that we were talking about in the past 1 hour. This is a sector that needs to be really understood. This is a sector which not only from the implementers perspective, but also on the MSME side, where people try and do their routine activities on a daily basis. We open the factory, we do something, we generate some turnover, we consume some natural resources. Probably when you talk about water, it's around 0.5 to 1 meter cube per day as on an average, I would say. This can be around, say, 5 meter cube to 10 meter cube or 20 meter cube to a maximum extent in, MSME. So, when we say water consumption in such a unit, it can be a 10 by 10 feet kind of a small, tiny unit also. It can be 100 by 100 feet or 2,500 square feet plot where you have an MSME generating some wastewater for which it is consuming some water. Almost 50 to 60% is generated as wastewater that flows out. What it does, how it does, we will look into it. Again, when you talk about an MSME or sector as a entity, there are several things that they lack. They lack access to finance, they lack access to market, they lack access, technology and environment, and so on. But we need to talk today on these two aspects, which are directly related to water and wastewater: technology and environment. Where is the best technology? Where is the affordable technology which can provide results, which can provide outputs, which can provide good outcomes for the, not only for the MSME, but also to the society at large. Wherever the industry have come up, what is the real challenge that the society or the environment is put into? We have to think about it. And towards this, what are the infrastructure bottlenecks each of these units present in industrial areas across the country? We have heard, 3,000 and odd industrial areas exist in this country, where each of these industrial areas house to around 3,000 to 4,000 units per industrial area. This is the size of MSMEs that are present in this country, and a huge scope of development, huge scope of improvement is possible in today's scenario on at least the water and wastewater sector. Leave alone the energy sector, leave alone the waste management sector, anything else, or air management, or anything you name. But water and wastewater requires a huge scope of involvement, huge scope available for, or potential available for improvement. Why? Cities likely to have 40% of India's population. Why we'll have to think cities as a population? Because cities and industries grow hand in hand. They all coexist in an environment. It can be a town, it can be a city. So the industries, the MSME units, and the residential population all coexist together these days. And if you see a city, it keeps on expanding. Greater Hyderabad, Greater Chennai, all that. So these Navi Mumbai. So when you talk about all these cities, they are expanding into a very large scale. And of course, the residential population and industrial population have to live together. That's how it is going on. And it causes a severe demand on services, particularly on water supply and sewage generation, its handling, stormwater drainage network. It's a huge, huge challenge in many cities. Effluent conveyance systems. Many people have, when we say so much of water is consumed, at least 60 to 70% is generated as wastewater. Whether it is treated or not, that is secondary question. But this has to be conveyed into a proper collection system, and it should be treated. It should be either reused or recycled, or it should be safely disposed. And on top of all this, you have a huge amount of sludge. sludge that needs several ways of handling. CPCP, the state PCBs, there are regulations, there are regulations for transporting it, regulations for handling it, the regulations for storing it, whatnot. How do we really handle all this? We will try and find out how this could be done. Currently, when you talk about MSMEs, why should I really do something? What is the really driving me to do something on water? We felt, at least these internal and external factors can help us in identifying why should they really think about this. I don't want to get into it because it is just around 5 minutes for me left to complete my PPT. I'll quickly get into other aspects. The national water policy and priorities, we have drinking water as the first priority compared to anything else. Nowadays, you might have seen the Central Groundwater Board announcing that mandatory licensing is required in terms of extraction of borewells or new borewells, or there are no borewells in certain places where you have permissions to dig it. So do MSMEs need to plan? Yes. Why should they plan? Probably of this reason. All our resources are from either groundwater, surface water, or rain. And to add on to all this, rain is the only source, as we all are very much aware that if you take groundwater or surface water, rainwater is the first source that builds up the ground and surface water that is available for our daily consumption. So there is a huge amount of, difficulty in harnessing all this on a daily basis, at least for the industrial purposes. So if somebody is an MSME in this, participants who are trying to understand what it is, how it is, they can think about this kind of strength, weakness, opportunities, and threat. They can analyze themselves in terms of where they are today. What are their strengths? What are their weaknesses? What are their opportunities? And what are the threats they are going to come? They are going through today. And what are the threats they will be facing in the next few years or few decades? I would spend more time on this, but due to lack of time, I will not get into this in detail. But somebody has to introspect in this quadrant of SWOT quadrants that I have placed here. You can think about this and you can still keep working on it. I have my contacts also earlier. After that, we can think of communicating with each other later. Coming to what is sustainable industrial production in MSMEs or industrial areas, we have some strategies. The only strategy that with an objective is to reduce pollution. With all these strategies, our aim is to reduce pollution in surrounding areas and natural resources, particularly the rivers, streams, and lakes. I will quickly get into an example for you to better understand how this could be thought about. And proposed scope of action would be something like operation and maintenance of water supply infrastructure and distribution and industrial wastewater management. We will get into it one by one when we have the Q&A also. We have a lot of time to spend during the Q&A. We can explain this more. And an approach which would be very, very generic to any kind of an MSME could be like this. They can augment their resources. They can do a water balance. They can identify a source of, utilizing the wastewater, utilizing several other techniques like somebody explained in the beginning, how technologies could be clearly identified and utilized. As an example for Delhi, many of you would be from the region of Delhi, or you might have visited Delhi and stayed in Delhi for many years. So this is how the flow path of Yamuna River. Why I'm saying Yamuna River is that the industrial or the city of Delhi, when it enters the city of Delhi, it looks like this. Yamuna as its, at its pristine best, entering Delhi near Jagatpur village. Probably you might have, visited that place, Wazirabad. But when it goes halfway, it looks like this. And when it leaves Delhi at Okhla Barrage, it looks like this. I'm not saying everything is coming from industry or MSMEs. We are trying to find out that how these industrial areas, I will tell you an example of Delhi where there are 3,000 industrial areas across the country, where Delhi alone has 33 industrial areas, as I said, coexist with the residential population. Sewage is generated, of course, it is treated by DJB, then if industrial effluents are getting treated using CTPs. There are 13 CTPs across the city of Delhi, but all this nevertheless still is not sufficient. Still, it is not possible for someone to reduce that pollution that you saw in the previous slides. One example that we can quote is electroplating industries in several of these industrial areas. This is the type of growth that they are expecting, and when this growth is happening, water consumption is also going to be enormous, and even the wastewater generation is also going to be enormous from all these usage patterns. Of course, the entire water consumption would be on this cycle of cleaning, rinsing, and so on, and then how to treat it, what is the best way to treat it. One example we have seen in Patpaganj in Delhi, where you have this kind of a treatment, which is again a zero liquid discharge setup. It's a small MSME unit which caters to 50% of the effluent generated is consumed within the process. Once it is treated, it is consumed back in the process, and the 50% is let out for CTP to treat it. These were some of the results that we got in in city of Delhi, where several of the units were taken into consideration. 2,000 units were taken into consideration. 50 units participated, and they gave us huge amount of savings to the tune of 35% energy saving, 29% water savings, and more. Why I'm saying this example? This is possible in an industrial area. There are 3,000 industrial areas, and imagine the amount of savings that we can bring to the society. MSMEs have a lot to contribute, and we have a lot to contribute to the MSMEs. We can do through several of these interventions that are possible. Way forward, I would or we would suggest that we need to strategize our water and wastewater management plans. Right from 0.5 meter cube or 50 meter cube, we'll have to plan ourselves. Whether it is electroplating, foundry, automobile, or any of these MSMEs, we need to plan ourselves so that we are able to minimize the load on the pollution, minimize our extraction levels by doing some improvement in the water use efficiency, reduce our specific water consumption, optimize reuse, recycle of wastewater, or try and achieve towards zero liquid. It cannot be 100% zero liquid discharge for anyone to achieve. And augment, the simplest way is using rainwater. I will stop here. I think this is what I would like to convey right now. And if you have questions right now, I will be able to answer. Probably in the next Q&A also I can answer. This is my contact details. If someone wants to have a contact with me, you can have it. Thank you.
Thank you, Mr. Sripati, for sharing this thing. I think it is wonderful work that the center in which you and your colleagues are doing. We will take one more of our presenter and then go back to the Q&A session. But I had a particular question, we had that I wanted to check with you, sir. Most of these industrial hubs have common effluent treatment plants. Which are either run by the industry associations or certain companies that come together. And I don't want to generalize, but generally when I visited a lot of these CETPs, I see that they are not functioning optimally. Or, I see that they are actually not, delivering to the full expectation level. Is it more of a technology issue? Is it more of a compliance, or is it more of an attitudinal issue in the industries?
There are, I would say, not all these three, or it will be a combination of all and even more, I would say. Because limitations are there, as I said in the beginning, there are a lot of migrations happening. There are a lot of limitations that are coming into the operational efficiencies of this entire CTPs also. Suppose you have a CTP with 10 MLD capacity, for example, Lawrence Road or Keshavpur industrial area in the northeast Delhi. It was supposed to get 11 MLD, but it is hardly getting 1.5 to 2 MLD. Why? Because of the reason that there are many companies who have started shifting from Keshavpur industrial area to several other parts of the city. And the water that is supposed to come to the CTP is not getting diverted into the collection system. It is either going through stormwater drains, or it is simply set into the Nala, or into the drains, or into the river Yamuna directly without any treatment. So these are all the several issues that that's why I said in the in an urban sector, the water supply system, the wastewater infrastructure has to be quite fine-tuned from the place where it is already existing. it requires a huge amount of effort by all stakeholders put together. It's a participatory approach that needs to be built over a period of time, and then things will start improving. So that is possible. But again, as you said, an attitude, a mindset is required to make this happen.
Thank you, sir. Thank you. I would request you if you could hold on for our Q&A session. I would now like to invite our next presenter for this session today, Mr. Harold Clevin. Harold heads the emerging markets business at Cambi International, a Norwegian company. So over to you, Harold.
Thank you. Let me share my screen. Let's see. So can you see?
Yes, I can see the screen.
Thank you. Well, thank you, Kailash, for inviting me and Cambi to speak at this conference today. We are dealing with the results of wastewater treatment, which is usually thought of as a second phase after treating the wastewater. We would argue that you should think about it right away as part of your plan how to deal with the overall wastewater treatment. What you see in the background there is our biggest plant in the world, treating sewage sludge from the entire city of Washington, D.C. and imports equivalent to about 4 million people, and producing about 10 megawatts of electricity and fertilizer from that wastewater treatment plant. Now, I will go on. Let's see, just a second. So what we all worry about in my sector, your worry is if you are starting worrying about what to do with your waste, that's where we start. And one of the things that we see is that you need to think about the waste part to be part of the so-called circular economy that everybody wants to, but the tendency seems to be, oh, it's a big problem, let's burn it or dig it down, which is not exactly the circular economy. So if you are worrying about, overloaded anaerobic digesters for biogas or biological sludge difficult to dewater, high quality requirement for treatment concerning pathogen kill and safety, maybe high disposal costs, which sometimes is hurting industries more than municipal sector, and odor issue, then we are the guys to come to. And I will go through some of the examples what we've done worldwide. And just saying that waste and wastewater management does not come for free. So usually what we see is a lot of countries have not existing regulation or lenient treatment of where to put the waste, and there's only a transportation cost. But the reality is that you should consider that a ton of sludge will cost you money to treat. Now, Cambi is a world leader in thermal hydrolysis, which is basically a pressure cooker, energy efficient pressure cooker prior to digestion. Most of our plants are on sewage sludge, both on municipal and industrial, majority being municipal, but also some common effluent treatment plants. And we also have plants taking food waste, fish waste, and other things into what we call co-digestion project. We usually see that the cheapest and most sustainable way is to produce a product at the end that can go to agriculture. Of course, with industrial effluents, you may have lots of heavy metals that you need to deal with, so it may not work, but you still need to reduce your volume, and if you want to take it to drying or incineration. And basically, we do this in three, various different sizes. We have, so the one in the middle here, number 4, is is this pre-treatment system we produce in-house, and then we supply the advice on how to integrate it into the overall system. So what are the benefits? Well, number 1, we demonstrate, especially on waste activated sludge, which is your nightmare kind of sludge, very rich in extracellular polymer, that we triple the digester throughput, or even higher with very difficult sludges. We also, our pre-treatment system is a pressure cooker and it's very energy efficient. So basically you get a pathogen kill for free. Is basically a sterilization process. you produce much more biogas. For pure waste activated sludge, we've seen up to 50% more biogas. You reduce your end quality and end quantity and of dewatered sludge after, or digestate after digestion, and you reduce your odor significantly, and you have a nice benefit of reducing your carbon footprint significantly as well. This is the pressure cooker, very simple. Basically what we attack is the biosludge, mainly as you want to denature it and you want to steam explode it, which we both do. A lot of research have gone into the right temperature and time for retention and for treatment of waste activated sludge from industrial and municipal sludge, wastewater treatment. And it's about 140 to 165 degrees C for 20 to 30 minutes. And basically, the step after that is a steam explosion step, which we depressurize the sludge after the reactor, which is where we get the main effect. This is just showing an entire biogas plant with a buffer silo. You have the thermal hydrolysis process, and you have a cooling step because it comes out of the thermal hydrolysis at about 100 degrees C. You cool it to digestion temperature around 40 or even higher, and then you use the biogas for cogeneration in most plants around the world, and then the cogen heat will then provide the steam for the process. So basically, it's not a perpetual engine, but it's a self fueled engine, process, that all the energy that goes into this will be given as a byproduct from the cogeneration. You can also upgrade the biogas to biomethane, and this just shows you how the processes continues in and continues out, but it achieves the required time and temperature to treat and denature the sludge in the middle. And that also is the pathogen kill requirement. We do primary sludge, secondary sludge, and biowaste. Most of the sludge in India would be secondary type sludge, either in the municipal sector from SBRs or from common effluent plants and so on. But we also have an effect on primary, but more than anything to kill pathogens, a very important thing nowadays. We can apply the thermal hydrolysis. Most of our plants, 56 of them, have a pre-treatment system. So you pre-treat the sludge before anaerobic digestion, thereby maximizing the digester throughput. And we have also some study with Thames Water where we put the THP in between digesters. So you first have a normal digestion step, and then you dewater, and then you pressure cook, and then do a second advanced digestion step. And then all these two can be combined with agriculture, in the sense that there is a requirement in the US called USA EPA 503 regulations for Class A, meaning pathogen kill, and that is being now used by municipalities in India and also recommended in the entire Namami Ganges project. If there is no requirement for Class A, you could consider only steam exploding the secondary sludge and mix it with primary. If you then take it to drying, incineration, and cement kilns, and then we also have a last application where you actually put it after the digestion, and you dewater the hot sludge directly in a centrifuge or similar, which is we have one commercial plant, and we have another one being built right now. This is just showing you the picture of what you don't want to have is the one to the left. Now, apart from stinky and smelly, and it's the volume of it. So this Washington DC used to have 1,200 tons per day of lime stabilized cake. You imagine all the lime you put in, and the cost of it, and the stink of it, and you had what's called a Class B. That became after THP and anaerobic digestion, 450, on almost a third of Class A cake instead, which is now being commercialized partially. The same in Poland. You see the sludge before and after. So not only the removing the odor and making a higher quality, but also reducing the volume. and this is what DC Water has done. This is the mayor of Washington, DC, opening the first plant and showing how this can be used at the White House lawn. And also it's been partially bagged. They sold 40,000 tons of their product last year, not through bags, but in general, all to soil producers and fertilizer manufacturers. What we've seen, these are independent studies done on carbon footprint. So whatever, if you want to go land application as a Class A, the lowest carbon footprint you will have, a lot of independent studies show, is thermal hydrolysis plus mesophilic anaerobic digestion. If you want to go drying, you also have the lowest carbon footprint with thermal hydrolysis, and the same with incineration. So just very quickly, where we have delivered around the world, 70 THP plants in 22 countries, serving approximate people equivalent of 107 million and 1 million tons of CO2 saved per year. Our biggest installation in Washington, DC. Second biggest is the entire city of Beijing. We also have Singapore, where it's combined with incineration. And then we have industrial plants in Norway, which I come back to. Just to very quickly, that the UK industry, water industry, has been privatized. It was privatized by Thatcher in the 80s, and the 10 big water companies all look for the cheapest available technology, maximizing shareholder value. And we are proud to say that we have been chosen to for all the major plants in the UK, and now treating more than 35% of sewage sludge in the UK through our systems, and more underway. This is just showing it quickly, the effect of a big plant. This is the Manchester, close to Manchester United Stadium. And here are 8 digesters, so 8,000 cubic meter each. By putting the thermal hydrolysis ahead of it, you increase the throughput of this from 40,000 dry tons a year to 3 times 120,000, using the same pumps, the same mixers, the same, just by denaturing, reducing viscosity of thickened sludge. And then they import sludge into this as a sludge treatment center, which is something we recommend also to look at for India to achieve economies of scale, which is important in any country. And yes, just to show that we are set the industry standard for robustness and availability. We have frequently more than 98% availability of the systems throughout the year. Very robust, been developed and improved over nearly 25 years. And we support the projects throughout their life cycle and offer various packages for service and maintenance and so on. And then we also quickly now get to the industrial sector. We have done, first of all, we want to say, what does the consultant say? So Arcadis, one of the world's biggest consultants, did a study on thermal hydrolysis on waste activated sludge from a nutritional facility. And a recommendation in this paper in 2016 was that thermal hydrolysis is suitable for food processing plants, breweries, distilleries, pulp and paper, and synthetic fiber. And that this nutritional products company sludge would easily be digestible after the thermal hydrolysis, and that depending on the gate fee, it would be economical. And they did an economic study, and they tested it at the lab at the Washington DC facility. And we have had our first, in 1998, we installed a thermal hydrolysis plant at replacing lysis with chemical lysis with thermal lysis or thermal hydrolysis. And this was run for 20 years as a success. And we also tested on waste activated sludge from petrochemical facility. We tested on various agricultural material like marks, grape pumice, and penicillin sludge from China, basically destroying all the penicillin remains, which would be a very important thing for the world to go towards sustainability in the future. And then we tested on Sasol's gas to liquid. This is South Africa's biggest taxpayer, biggest gas to liquid facility in the world. And this test shows you, basically, this is after you have hydrolyzed it, so it becomes liquid, and before you see how thick it is. And basically, this is how thick it was. and it's not possible to pump or mix, but then it becomes liquid after. So this led to, we signed in February a full-scale demonstration, commercial demonstration at the Sasol Synfuel Secunda facility, world's largest coal-to-liquid plant. And we will supply that, and then the aim is to use industrial, just a second, biological sludge as feedstock for the gasification process, coal gasifiers, and then they want to reduce their waste generation and greenhouse gas emissions. And we were selected for proven reduction in viscosity and killing pathogens for safety. And should it be a success, they will upgrade it to full scale. And again, an example of other types of material. I'm getting close to my end. And this is just a very quick, just an idea of what you can do with other material. This is liquefaction of something that looks dry. It's actually grape residue pumice, and it can be liquefied and then digested. And what about all the straw that's burning around Delhi? Well, you don't have to gasify thermochemically. You can actually do a biological treatment, where you have controlled emissions, and you also have an end use of the material for fertilizer after. And what about the enormous amount of pollution going from the landfill in Delhi? You have 9,000 tons of MSW per day, and 4.5 of that, probably more or less, is biodegradable. And now we've delivered 5 biowaste plants, including for the city of Oslo, and 2 kilos of food waste would drive a bus 250 meters. That means that from just that landfill, and not considering sludge or anything else, just from the food waste, if you could capture that, you could drive your 6,600 buses in Delhi nearly 100 kilometers each per day. So conclusions, THP can be used to treat industrial wastewater sludge from effluent treatment plants, common effluent treatment plants, STPs for industrial townships. What we recommend is sludge treatment centers to get economies of scale. So people have to work together, or someone has to develop the project as a PPP or as a BOT or whatever. And we are partnering with the principal scientific advisor to the Indian government to set up centers of excellence. What has already been planned to be set up in IIT Palakkad, Kerala, and we are invited to be part of it. Another COE is being set up with, which will target organic waste and industrial waste on our initiative. Thank you.
Thank you, Harold. Thank you for sharing this presentation. We have a few questions which I will take up with you. We have Saurabh Datta who is asking a question. What are the key advantages of putting THP before anaerobic digestion instead of taking sludge directly to digestion?
So the key advantage, as I said, is viscosity and retention time needed in the digester. So if you take waste activated sludge and try to feed it to a digester, you will maximum be able to feed the digester at 4 to maybe 6% solids concentration. That means 94% water. Otherwise, it's too thick. Now, if you liquefy it with a thermal hydrolysis, you can feed up to 12% or higher. And we have had the facilities been able to feed up to 14%. You will challenge yourself with a buildup of ammonium, but you have industrial anaerobic digesters running at high ammonium. And then you also have proven that the time needed for retention time needed in the digesters is scientifically proven to be 8 to 10 days max. Now we usually design for 15, but thermal hydrolysis, the work by Dr. Higgins and Bucknell University has proven that you run your digesters down to 8 days. So if you combine those two, you will even have a bigger reduction in digestible. And now that Mumbai and other cities are valuing their land, and not just the construction cost of a digester, you should think of how many square meters you can save by doing it more compact, which is industry's standard anyway.
We have one more question from Sudhir Singh. He says, can you share with us some information about distillery fermenter sludge utilization method?
Yes, so we have done, the ethanol industry was going to save the world in when Al Gore released his video on carbon footprint in the 2000s, and then we did tests on distillery material, waste from distillery. The competition was, of course, the corn that they use should go to tortillas instead of ethanol. Number two, the end product could go to be eaten instead. But we did prove that we can actually digest it after it's thermolysis. And then we had the grape hummus, which is a big waste from wine industry and so on, has a huge effect on PHP. And we've done lab analysis, no full-scale plans on that.
We have an anonymous attendee who is asking the question, are there any case studies on the examples you showed about penicillin and others?
Yes, we have to check the NDAs and everything, but I believe there's, we can, please to contact us, because I think that is something we really need to look at in our world, both in India and Norway and other places, is to break the penicillin and the antibiotic cycle and the pollution of the environment, with and now with the increasing problem of bacteria resistant to antibiotics.
Okay, one more question we have from Mahesh. He says that there are well-known examples of, the end product from municipal sewage being used in agriculture, but with industrial, wastewater and effluent, can, the final end product be used in agriculture in an industrial scenario?
Yeah, that depends, of course, on your industrial process. So if you have a process that generates a lot of heavy metals and too much of it, the heavy metals are sometimes what the soil need anyway, like copper and manganese and all. But yes, if you have a food processing industry, I see no problem. If you have a paper and pulp, we did a study for Mondi in Poland, where they actually had a whole plan to sell the end product, and then the reject water from the final dewatering was actually set as a, like it's very rich in nitrogen and phosphorus, and was used in the project idea as a source for nitrogen and phosphorus in the wastewater treatment plant, because it's very carbon rich wastewater. So yes, depends on but otherwise you need to get rid of it in some way, and you need to stabilize it. You need to make sure that people dealing with don't get in touch with pathogens, and you need to reduce the volume before you take it to drying and incineration. So a lot of paper factories will mix their waste activated sludge at 10% solid with their primary sludge, which is fiber rich, and then take it to the fluidized bed because they have a big one. But that's burning water. It's not generating energy. So do something better with that fraction, and we can do that. We could do 10%, maybe 10-15% solid waste activated sludge. We could steam explode it, digest it, and then produce close to 30% solids end products, and possibly for agriculture, or at least reduce the volume dramatically.
Okay.
While generating energy.
Okay. Thanks, Harold, for sharing this presentation and information with us. We have a few more questions that are there for the other panelists. So do we have Filza still present with us?
Yes, we are still here.
So we have a question from Devan Sharma. He says, could you please identify the ATV document number for aeration control?
Yes, there are two main important letters. It is 229. The number is 229. This is one important letter, and the other one is 265. These are the main important DWA letters for our products.
German advisory leaflets.
Okay, we have a question from Jain Irrigation Limited. The question is, can we use this system for application of fertigation?
What is fertigation?
Fertigation?
Yeah, I think I will ask, the question to be re-put in the box. Okay.
Yeah, we have a look in the box, yeah. So
we have Devan Sharma who is asking a question. What is the preferred location of sensors? DO sensors, NH4 sensor, and NO3 sensor?
So we can give a recommendation for the placing the sensor. So typical position for ammonia sensors are, for example, 2/3 in direction to the effluent. But I would suggest to follow the recommendations of the manufacturers of these sensors, because we are not the manufacturers of these sensors.
Okay, the question has been put back, Michael. So the question from Gen Irrigation System is, can we use it for the applications of fertilizers? Fertigation, he says, is primarily fertilizers for agriculture purpose.
I have to take a closer look on that, on this application. So maybe there's one possibility to speak about that with more information. Then we can evaluate whether there is a possibility to use our products. So I would like to invite you to send us some more information.
I will send across the details. We have Manohar Sivara asking a question. Do you have any standard sizes for the, the system you showed us?
So we are doing our design based on the actual airflow rates. So we are asking for minimum and maximum airflow rates, and then we give you our recommendation regarding the size of the valves, for example. Yes, and our calibration, we are doing also project specific based on the actual site situation.
Okay. We have Sudhir Singh who is asking the question, how does the diffuser auto cleaning work happen in your system?
How does what work?
The diffuser auto cleaning work.
The auto cleaning, yeah. So the manufacturer of the diffusers tell us, for example, please do flexing. So to give more than normal air to the diffusers to solve some solids, for example. That is one possibility. Then we can also do pressure release. So then the manufacturer tells to release totally the pressure of the membranes, and they fall together, and then the solids get rid of. And another possibility is to clean it with acid, for example, and then we can use a certain airflow rate, and then a pump is connected with acid to clean it by acid.
Okay, Jeevan Jacob is asking the question, how are the control valves controlled? Are they pneumatically or electrically controlled?
Our actuators are mainly electrical, because we have experience that the electric actuators have a lot more better performance and a lot more better accuracy. So in most of the cases, electrically, yes.
Okay. Let me just see if I'm missing out on any questions. Okay, John McGrath is again asking a question. What equipment are they currently using for measuring nitrates and nitrites?
So we can use the signals of, typically they are using ion selective sensors, but we can also use the signal of an analyzer, of a stationary analyzer. So this depends on the location where he wants to measure the NH4, for example.
Okay, I think I've come to nearly end of all the questions. Okay, there is one that's just come up from Tejasvi. This is to Filza. Can your technology be used in SBR, MBR process STPs?
Yes, you mean sequential batch reactors and membrane?
Yes.
Yes, it can be implemented, but of course, case to case, each plant, each design is different. So we do a plant evaluation beforehand, and then we do the recommendations and make the offer. Yes, we can apply it.
Okay. This is a question to Mr. Shripati from Nikhilesh. He's saying, sir, can you elaborate on the infrastructure bottlenecks that you mentioned about in your presentation?
Yeah.
So as I mentioned in the beginning, when you are in an urban environment has to cater to the coexistence of industries plus the residential colonies. So infrastructure becomes a huge challenge when you have to cater to these two types of segments or types of people. So the requirements in a MSME kind of an environment would be different from a residential environment. Since both are existing at one point of time, it will be very difficult for any planner to allocate these resources, the water resources, the energy resources, and so on. And in addition to this, the ecosystem is also to be taken care of. Flora, fauna, fish, the mammals, and whichever they are surviving in the rivers, lakes, streams, and something nearby, ponds nearby. And over on top of all this, rain becoming the only source of water, how do we really cater to, getting the best use of this rain? We have seen in cases of Delhi, 800 mm and above is the average rainfall. When this amount of rainfall is available, how do we really utilize this? Should it be sent without doing any kind of storage or recharging directly into the sea or into the the Yamuna River? It's a big challenge. That is what we mean in terms of the infrastructure challenges. In fact, it should be challenges, not bottlenecks alone, where the infrastructure crumbles over a period of time. When you say the DJP is laying so many pipelines, that is maintaining, but how much is the percentage of water that they are receiving at the end of the MSMEs or the beneficiaries? For say, suppose you pump 1000 MLD for normal water supply, how much do they get in their user end? Is it 500 MLD? Is it 600 MLD? Or what is it? And the second part is wastewater. When you say wastewater, we mentioned a classic example, Keshapur Industrial CTP. 11 MLD is the potential it can cater to, but they are getting only 1.5 MLD. Where what is happening to the other 9 MLD or 10 MLD? It is not even understood. In the sense, we can calculate, we can put numbers, and everything is possible. But the entire society has to understand this. Infrastructure is not only by the government or the infrastructure agency that is providing. Say, for example, Industrial Development Corporation in Delhi, DSIIDC. It is a question of how every person in the entire, industrial area come together and do this activity. That is how infrastructure bottlenecks. If you start one thing, you will have to pan out into several things and start addressing each one of them. Then only it is possible.
Okay, thank you, Mr. Shripati. A question to Michael or Filza from ONGC is, what are the typical maintenance related problems with wastewater treatment plants?
So yeah, typical problems are, for example, as I mentioned before, are the under and over aeration in the process itself. And some maintenance issues regarding diffusers, some fail-safe strategies for the blowers that they are not tripping. So these are typical events, and yeah, we can support there, and we can ensure some hardware reliability, let's say.
Okay, one more question for you, Michael, from the city of Cape Town, the municipal authority there. They are saying, how can automation initiatives change and improve operational and maintenance activities at municipal treatment plants?
We will support, let's say, a tool, and the operator of the wastewater treatment plant can work with this tool. It takes nearly let's say a few hours of training, one day training, and then they are able to work with our controller by themselves. So the algorithm is open, they can influence and they can work with that. And then hassle-free and without taking the process itself under risks. That is important.
Okay, I'll take one final question before we close for today. So again, this is for you, Michael. The question is from Dr. Dinesh. He says, how vacuum mask technology use can be favored for water treatment plants?
What was special?
You mean if our technology can be used to wastewater treatment plants? Yes, of course.
This is our key market.
Our main segment of our business.
Yes.
Okay, thank you. This brings us to the end of our session for today. And I would like to thank all of our presenters, speakers, and experts, panelists who have taken time out of their schedules, shared their knowledge with us, and most importantly, stood by to answer patiently all the questions that have been put up. I have tried to take as many questions as I can. In case I have missed out any questions, I will be sharing them with all our speakers. and they can take it up, or they can reply to any of the the questioners directly. This brings us also to the end of the season 1 of the industrial water and effluent treatment series. We had conceptualized this as a platform, for all the industrial sector people to come together to share knowledge, ask questions, and basically engage with each others. And I think over the 5 episodes that we have had in the last 5 months, we have interacted with close to around 2000 to 2500 people and answered close to around 800 to 900 questions. We will be taking a slight break of 2 months before we come back with the second season of the IWET series. And for the next 2 months, we are also going to launch our municipal initiatives. So I would like to thank everybody who's been part of these sessions for us over the last 5 years, our speakers, our attendees, our experts panels, without whose support I think this initiative would not have seen the kind of success and response that it has seen. And we will very soon announce the dates for season 2 and keep all of you informed. With that, I would like to thank all speakers, panelists, and the attendees, and I bring this session to a close. Thank you. Thank you, everybody.
Thank you very much.